Hey, I'm Chad, and today I have Jody from Welding Tips and Tricks with me. I can't believe I'm actually sitting here. This guy is the godfather of welding on YouTube, so somebody like me, I feel pretty honored to have the opportunity. And I came to Jody. We were actually at an event together, and we were talking, and I mentioned that I'd gotten a new TIG welder and that I'd gotten a little overwhelmed. Jody has agreed to sit with me, kind of walk me through what all these settings are. And I just wanted to ask him about a few other things other than just the machine for somebody like myself who's a beginner welder. When I first got this machine, the first thing I did is I went into my local welding shop and I picked up a bunch of tungstens. And you can see here I got all kinds of different ones. And I started talking to Jody about it. He's like, well, really all you need is this one right here. That's probably all I'll need. And so tell me a little bit about that, like what's important when I'm looking for tungstens and where's the best place to get those?
Well, there's a lot of different options. There's no one that's perfect for everything, but there are several different options now that are multi-purpose electrodes. So a 3/32 2% lanthanated electrode will do anything this machine will do. It'll handle all the way up on the high amperage 200 amps on AC, and it'll handle low amp DC starts if you sharpen it like to a needle for the low amperage stuff. So there's really no need in having.
And those are always going to have the blue on them?
Yeah, typically they're kind of a sky blue.
Okay.
I do sell them on my website, on my store. My store is at Weldmonger.com. I only sell 2% lanthanated because I believe that strongly in it. It just simplifies things for, especially for makers, people that I just want to weld. I don't want to, pass an X-ray test or weld in a clean room. I just want to weld and have a good looking weld, and it just simplifies everything. There's no point in having pure for this and this for that, especially on inverter welders. You can get a lot out of just that one electrode, and I don't think you'll ever need anything else on this.
Okay. And what about the filler rod? I mean, I've got, I don't know, half a dozen different kinds. And
yeah, filler rod it depends on what you're going to be doing. Right off the bat, you want to get some ER70 S2 or 6. A lot of people really prefer the 6. It's a little bit, not every welding supply has the ER70 S6 in stock. All of them will have the ER70 S2. I'd start off with 1/16 diameter. It might be all you need. I'd probably get some 332 as well. And you'll find out what you need from there. If you're going to be welding on really thin stuff, you might even drop down to 0.45. But that's the start. And then, of course, if you're going to weld stainless, I'd start off with the same thing, 1/16 and ER308L. Because that's the most commonly used. It's used to weld 304, but 304 is the most common stainless everywhere.
Okay.
There's many different grades, but that's a good starting place. Just get the 1/16. Once you get into it, you'd probably want to get 0.45 as well. Generally speaking, on stainless, one size smaller filler, especially for sheet metal, works better than what you would use on carbon steel. It's a good rule of thumb.
Okay.
But so now we're at ER70 S2. ER308L, and then for aluminum, 4043 is a good place to start.
4043. Okay. So these come in like a little case, and I noticed that a lot of the welding supply places have the big plastic cases for storage. I'm probably not going through this stuff very fast. How secure are these for storage, and should I invest in the cases to keep my filler rod in?
At first, I wouldn't invest in cases. I think these are fine.
Okay.
Basically, for instance, it's going to keep most of the moisture, and it's going to keep all the dust off of on all of them, basically. And your aluminum is going to be the only one that's really going to kind of, over time, sort of get a little bit of a cloudy-looking corrosion film on it. It oxidizes. Mm-hmm. But you don't want to, if you're hardly ever welding aluminum, you don't want to have 20 pounds of filler wire stored away. Just, you kind of want to have it by the pound.
Back to the tungsten, another thought I had. When I first got the tungstens, I realized I was going to have to sharpen these. And so I went through all kinds of iterations. I tried the angle grinder. I have a 2x72 and I also have a 6-inch grinder or sander. belt sander, and I was initially just using a drill and spinning it on the sander to get them sharp, and it was working. But I was concerned that, you know, having inconsistent angles and, you know, it was going to affect my ability to weld consistently. And I've heard different opinions. What do you think?
I think a tungsten sharpener is nice to have, totally not necessary to start with. You know, somebody sent me one that I use sometimes, but I never bought one. I bought one with the company card when I worked for a corporation because that was their money, you know, and it made sense because it was aerospace. But
Right.
awful lot of guys even welded on aerospace parts, just sharpening on with a belt sander.
Okay.
It's just you know, it does make a difference. It just doesn't make the kind of difference that you might think it would, especially as a beginner. If you've got a somewhat blunt taper versus a needle point, you know, again, there's slight differences. You know, I've done videos on the difference in the penetration profile between the two.
I actually watched that, and I was kind of surprised because I thought that the sharper that profile, the deeper it was going to penetrate, and it was actually just the opposite.
Right. So if you sharpen it like a needle, you get a nice, crisp, low-end start, but you get shallower penetration. Might still be enough penetration, but, you know, if you really want, I think something in between blunt and needle, about 30 degrees is the best all around. That's what the video showed, and I did lots of testing on that. I did lots of testing on 2% lanthanated electrodes to see which was the best all around electrode too. So that's what I came up with, and I don't think it's the best spin in the world. They're cheap, they're getting a lot cheaper than they used to
so
be.
this is a Dremel. I already own this, so
Yeah.
just a Dremel multi-tool, and this is just an attachment. And I got this off of eBay, and you know, if somebody wants one of these, I'll put a link in the description. But pretty inexpensive eBay find, I guess.
So
I
how
also
much do
found
you
a-
have in that whole thing?
I don't even know how much a Dremel is nowadays, but I paid, I think, 35 or 40 for this,
Okay.
and it came with several grinding wheels. That said, I have a 3D printer, and I found on Thingiverse, I found a file. I just downloaded it, and I printed out a similar setup to this. The only difference is the one that I printed out, it actually has, I think, 3 angles for 3 different size tungstens as you spin around it. The holes
Right,
are
right.
into this. So I think it's probably actually going to be a better value, but not everybody has a 3D printer.
Gotcha.
But a lot of the people who put those files up will actually fulfill that print for you for a small fee. So that might be an option for
Yeah.
somebody who wants to get into it cheap and they already own a Dremel.
Well, it's a super handy way to have a way to sharpen your electrode right at your bench, you know, especially they have cordless Dremels now. And,
Yeah, I
and
mean,
whatnot,
the
but
one thing, and I probably won't show on here, but, you know, I get an absolute consistent, you know,
right.
it's always the same every time. So
Yep. That's the benefit. That and being a diamond wheel. But for a beginner, the diamond part of it doesn't really translate into any real benefit.
that just
for
makes
you.
it a smoother grind, I
Right.
guess.
And you're not contaminating, you're not embedding aluminum oxide in your electrode, which is a possibility. But, you know, for years, that's all that we did is sharpen them on a bench grinder with aluminum oxide, and you know, been a bazillion X-ray welds made that way. I'm not saying that's the best, but it's just, I just don't think that it's the best spin for
It's
a
not the
beginner.
best. Okay, not
Yeah.
the best place to spend your money up front. That's good. Good to know. I guess the main thing is practice.
Practice. Practicing with intention, you know, like it's good, you know, to pull up a video of somebody that's doing it correctly and then not welding too many beads before watching that again, you know, avoid building those bad habits and up.
Yeah, so one of the things I started doing, I didn't know, I don't know if it's in the book or not, I apparently missed it, but when Jody was showing me the panel, he held down the pedal for like 5 seconds, and that made it to where the pedal was actually giving me control. Previously, I was kind of using the pedal like a switch, like if I had a TIG torch with a switch on it. It was basically, I got into a habit after he switched it over of just tapping it when I was starting it and then letting off instead of holding it down to get the accurate.
You didn't realize it wasn't operating like it was supposed to as a pedal.
I kept thinking, you know, I know I'm supposed to have control, but it just seems like it's just a switch.
Right.
And I knew I was going to be over here, so
Yeah.
I thought I'll just wait and talk to you about it.
And all machines aren't like that. This particular, I read in the manual on that one that you had to press it and leave it pressed for about 5 seconds, and then it would sync up to know that it was you're using the amperage on the foot pedal.
Okay.
And a lot of other machines, once you plug the pedal in, it knows.
Recognizes
and
it,
it
okay.
doesn't. You don't have to do anything else. But so that's just a good example of knowing the ins and outs of a machine. Because if you don't, it's kind of like knowing the ins and outs of a camera. If you don't know, you don't get the best value out of the camera, right? If you don't know all the little details.
And I guess I could see where it would be an advantage for it not to immediately recognize. Because if I wanted to use it as just a switch, and I was up underneath a car welding, and I didn't have the, you know, just like if I had a TIG torch with a switch on it, it would replace that without having to get a new torch.
What's wild to me is, and this is kind of adding to the confusion over the years on welding machines, because this one is full of capabilities, and yet the area that all those capabilities are displayed here is like the size of a wallet. You know, whereas 30 years ago, the face of a machine was more like, you know, Mona Lisa, or, you know, big knobs that are spread out, plenty of room to put the icons and the pictures and instructions, whereas this has got a little bit of toggling and a lot of information is in that little area right there.
And, you know, compared to MIG welding, which is what I'd started off at, actually I started off with flux core, I wasn't even doing MIG. You know, when you pop open the hood on the side where the wire is, it has all the settings, everything is right there, it's pretty clear cut. And then I get into this and there's
upslope,
downslope. I was like, I don't know what any of these numbers mean. Are they meaningful? And actually the way I was using it, it actually had meaning because I was using my foot pedal just as a switch. But a lot of those things aren't even programmed when you're using the foot pedal. It's not used, which is new. I didn't know that. So
yeah, good point. And see that's why there's also a market for simplified machines. You've heard of a Miller diversion. It's a TIG machine that basically has, you know, material type and thickness are the settings, and so the material type changes polarities for you, and the thickness changes amperage for you. So it's basically got a couple of knobs, and the post flow is fixed. And you know, some people like that. Just that I don't want to have to know all that. Just let me dial this thing in, and you know. But with the complications come added features. It's a more capable machine, you know. With the upslope and downslope, you could even use this for an automated power source, doing something on a turntable with a remote switch.
Oh, wow.
You know, you could hit it, and it would, as that table was turning, it would ramp up, and then you could hit it again. It would ramp down when you had done a revolution. So it's a much more capable machine.
So I could actually
features.
I could actually put that torch in a fixture.
Yeah.
And then just basically automating it.
Oh, yeah. When you get the machine, you get the torch, the foot pedal, and a flow meter. So you got to get argon, right?
Yeah, that was another thing.
Did you run into any issues there when you were at the local welding supply?
I didn't have any issues getting it, but you know, of course, I had gas for my MIG, and you know, I thought, okay, I'm good to go. I got my gas, and then I realized, oh, wait a minute, I need a different gas.
Okay.
And I thought initially that I was going to have to get another tank to do aluminum, but I think you kind of set me straight on that. I don't.
Yeah, you don't.
Actually.
Argon is pretty much. You could probably. It's probably all you'll need. You could get. There are some mixed gases specifically for aluminum. There's an active gas, Stargon AL is one trade name for it. You could also mix helium in, but I'm guessing that you're probably not going to. Yeah, you don't really need it. It just extends the capabilities.
Okay.
You know, it's a upgrade, and because it's a 200 amp torch, I mean a 200 amp machine. If you were to try to weld, let's say 1/4 inch thick aluminum, you wouldn't have quite enough amperage. But by mixing, like say 50-50 helium, it makes it more like a 250 amp machine on the output for aluminum.
Oh, okay.
So, but if you're not, unless you're doing it, you don't really need it.
Last thing that I wanted to ask you, this machine has a plug. I can use it as 110 or 220. Obviously, you know, my gut tells me that more power is more better.
Yeah.
Tim, two-man, you know, more power.
Yeah. The 110 is
what are the limitations when I'm using it as a 110 machine?
Mainly amperage. You're just going to get about half of the output on 110. Like, I don't know what the specs say on this, but you know, you might be able to get 100 to 125 amps out of it on DC. Might be a little bit different on AC. You're just not going to get the full amperage when you're plugged in on, you know. And so if you want to just practice on sheet metal, it won't affect the quality of the arc or anything like that. You just won't be able to weld thicker stuff.
Okay, that makes
Here
sense.
it says remote. One thing a little bit tricky about this that you have to remember: when you hook the foot pedal up, when you plug the foot pedal up, turn the machine on, you need to press the foot pedal and leave it pressed for several seconds. I think it's 5 seconds, a little bit. But leave it pressed and you'll hear the machine beep and this little light will come on. Now it's in remote mode. So now it recognizes that it's using a foot pedal, and so all this 2T and 4T stuff over here doesn't come into play. You strictly are using the foot pedal. So your upslope and your downslope, that's all manual now with, you know, how much foot pedal you press. All right, this is the main amperage adjustment, as well as, I guess, the main encoder button that, you know, will change these functions here. When I press it like this, that's my downslope, and then I can set each individual setting with this button. 2 seconds downslope, finish amps is 5 amps, or actually finish, no, wait a second. All right, post flow's on 6 seconds, then it should go right back to the main amperage. All right, pre-flow, you might have to edit a lot of this. Pre-flow, right here, half a second. You don't need any more than that for carbon steel. In fact, you could probably get by with a little bit less, but I'm going to leave it at where it was at. Start amps is at 5. That's the amperage it'll start at. You can set it higher if you're welding on something really thick and want it to be a nice, crisp, sure start. But won't hurt to do 5 either. I hadn't had any problems so far with that. Upslope. That is the amount of time it takes to go from your start amperage up to your operating amperage. And if I was using a torch trigger, I'd probably have it set at about 2 seconds. Operating amperage, again, about 1 amp for carbon steel, about 1 amp per thousandth of an inch, up to 1/8 of an inch. And after that, you start needing a little bit less amps. Like, you can almost weld anything, no matter how thick, at probably 175 amps just doing multiple passes, you know, on steel. Not on aluminum, but on carbon steel. So that changes, but it's pretty accurate all the way down to really thin stuff, say 20 amps for 20 thousandths. You won't even need all of that. You can operate, but it'll get you right in the ballpark, and you can use the foot pedal for the rest of it. So 125 amps there, that's your operating amperage. Downslope, 2 seconds. You can set that however you need it, but
And what's
again,
the downslope again?
that's it. That's tapering off the amperage. When you're finished welding and you want to taper down to your end amperage, let's say you're at 125 amps and you're getting, let's say you're getting close, let's say you're using the torch trigger, torch switch. You're welding 125 amps, you're going along fine, but now you get to the end of the metal. All right? Your choices are either to shut off all at once to not blow away the end, and then you're probably going to leave a little crater dot, which is a defect, or you can taper off the amperage and avoid blowing the end away and avoid a crater dot and have a nice ending to the weld. So, you know, downslope, you know, you just have to play with that. It's different for different thicknesses, but if you are using a torch switch, you know, I'd probably want it maybe 2 to 3 seconds.
So when I was first using this, I was kind of using the foot pedal like a torch switch. I was just turning it on and off.
Exactly, because you hadn't done this operation here and made it recognize the foot pedal.
Right.
So even though you were using the foot pedal, it was pretty much a switch and relying on the settings that you had here for upslope and downslope.
Okay.
It's kind of tricking you a little bit, right? Finish amps, again, that depends on the thickness you're welding.
Okay.
It's time, it's amperage and time.
Oh, okay.
Okay, yeah, so when I get to finish amps, 5 amps, but I can also have it hold 5 amps for however many seconds before it turns off.
Okay.
So it doesn't just, you know, I would say that for most operations you won't even need to do that. Once it gets to 5 amps, you'd want it to just turn off. But it is an option. So you have amperage and time there at the finish. Okay.
Cool.
And then there's your post flow. Again, 6 seconds probably plenty for carbon steel with a 332 electrode, especially when you're first learning, because it's just not going to make much difference. You're just wasting gas. You know what I mean?
I do.
Yeah. Okay, now down here, AC pulse, and that takes me to the base amperage background for my pulse, but then this is AC frequency here, which goes up to probably 250, yeah. Okay, AC frequency is adjustable, and then AC balance, and that looks to be a percentage of cleaning. Yeah, so it goes from 15 to 50. So it's backwards from a Miller Dynasty. The higher setting is going to mean more cleaning. Okay, and then I press it again. Now it takes me to my percent pulse time, which is kind of weird. I would kind of want it to set both pulse settings at the same time. So this is percent pulse. Doesn't make sense to me. I'm sorry. Percent pulse. That's frequency. No, that's pulse frequency. Hold on. Okay, hold on. We're gonna have to do this over. Otherwise, it's gonna be too. Sounded pretty good. Oh yeah.
Actually, looks like a weld.
Yeah. Yep. So, like I said, foot pedal, well, it's still like steel in that once you get your amperage right, you don't do a whole lot with the foot pedal. Not like you're like up, down, or anything like that, but, you know, it's a little more sensitive as far as how much you got to press to get the puddle started, especially if that piece were like 4 feet wide and 3/16 thick, you would need a lot more heat, especially at the beginning. And then after you ran a beat or two, the whole thing would start to get warm and it would take less and less amperage. Like right now, you're set on 120. When that piece was cold, I probably needed all 120 to get my puddle going. You're probably only running 100 amps now, you know.
Oh, okay.
In fact, I'm going to look and see what it's reading out when you run the next one. But that was a good one. Whatever you did there, do it again.